Okay, this is the video for climate topic 2, climate change, right? This is the review of climate topic 2, climate change. This series of video is to be used together with your cluster assignment, right? So there will be points in which after we've covered a certain amount of concepts here, you need to go to your cluster assignment and complete the accompanying question, okay? So once again, what are we looking at in terms of climate change? We are looking at the natural, a few key things to get a general understanding that climate change can be natural, okay, and more importantly, how anthropogenic factors can contribute to climate change, which are human factors. Okay, anthropogenic is a key term. You need to learn how to use this term instead of using the word human factors. Use the word anthropogenic factors. Okay. Next, we will then move on to analyze how climate change affects natural as well as human systems. So climate change is real. You cannot run away from that, right? But there is a natural cycle of climate change itself. Okay, so without the intervention of mankind, the climate does also go through cycles, right? Things like your climatic cycles, okay, that they have used variety of means to track. Okay, they show that there is a cycle of increasing and decreasing temperatures throughout the history of the Earth. Okay, so is it really fake news? Not really, right? Please bear in mind that this is saying that climate change is completely natural is not using empirical data at all. Okay, because modern data has shown that while there is a natural cycle to climate change, right, which can be evidenced from analysis of C4 sediment and oxygen quantity that's within the sediment layers, right? Also in the ice core samples, they can actually count the oxygen isotope that's trapped within, and they can give you an idea of how average temperatures have changed over the history of the Earth. There should be no argument that with the rise of human beings, right, especially after the Industrial Revolution, we have actually accelerated this climate change cycle rapidly. Okay, so how do you actually do this? It's actually core sample analysis. It actually just tells you which part of the depth, right, has higher concentration or lower concentration of light or heavy O2. That tells you whether the climate at the moment in time is heavier, it's warmer or cooler. These are background information that, like I said before, this is not something that you need to know in great detail, okay? But you need to know that over the years, there is a natural phenomena whereby the climate of the Earth has changed, okay? Another thing that we can see is if you look at the tracking of global ice coverage. Okay, global ice coverage. And these two images here, right? This is another sort of evidence that can be used to show that there's a natural climate change cycle, because 18,000 years ago, the Industrial Revolution hasn't taken place. So the warming actually wouldn't have been unrelated to us. Okay, so what are the two key causes of this natural variability? Okay, one is of course the change in our orbit and angle of tilt, and secondly, in the short-term sequences, there are certain things that can happen that can increase or decrease the temperature of the Earth. So let's look at the first one, the long-term one first. Okay, this one deals with the tilt and the angle. So at certain moments in time, right, the shape of the elliptical orbit that Earth takes is not a sphere around it. Okay, it's like an egg, and that shape changes. So there are moments where, due to the change in this elliptical shape, the Earth is at moments nearer to the sun, and as a result, you have heavier exposure to sunlight. Okay. Similarly, when there's a tilt increase, okay, the tilt is not a fixed tilt. Okay, unlike what we in the earlier parts of geography in lower sec, we make it fixed so that it's easier for you to understand. But in the real world, nothing is actually fixed for long. So the tilt actually still varies. And when there's this variation at moments where the North Pole is facing nearer to the sun, you will have increased solar radiation experience. Therefore, you have warmer temperatures on the Earth. So these are the reasons why you have long term, right, the long thousands of years cycle, right, you have actually temperature variations experienced on Earth. It's nothing to do with mankind. Okay, this is natural causes. how much of this you need to know? You do need to know that there are natural causes. The exact details are not key. The key thing is the anthropogenic ones. Okay, sunspots. Okay, sunspots is the short-term variations that we can actually observe. There are moments where the sun actually releases higher amounts of energy, and from Earth's viewpoint, right, when you look at the sun through the apparatus, the long distance, what do you call those, telescopes, right, you actually see them as black spots on the sun itself. These are moments where there's sudden increase, sudden outburst in solar radiation. What do we feel? We feel a spike in temperatures. Consequently, if we have localized large volcanoes that erupt as well, you can also have local climatic change, right? So, for example, the one that is given in your textbook as well as in SLS is Pinatubo, right? In the 90s, when Pinatubo erupted, right, there was a large amount of ash that was ejected. So this actually helped block off, like what you see in the diagram here, right? It blocked off the solar radiation from reaching the surface of the Earth. So when you block that off, right, what happens is the surface actually doesn't get enough or doesn't get the regular amount of solar radiation, and it becomes cooler. Okay, so it actually reflects a lot of the solar radiation back out into the atmosphere. We have a temporary cooling effect. This is called solar dimming. Okay, so that is basically to give you an understanding of what can happen even without human intervention. Now we're going to look at the more important one. What happens when you have anthropogenic factors or human factors? How do these human factors contribute to climate change? Okay. Facts of life. We are approaching 8 billion humans, right? We have continued to increase. As a result, the quantity of greenhouse gases has increased as well due to the varying users that we have, and due to also the burning of fossil fuels. The continued burning of fossil fuels is very important here. So I'm going to write this down, right? The continued burning of fossil fuels is one of the key problems here. Okay, so this comes from the burning of fossil fuels. Okay, another thing very important about this burning of fossil fuels is there has been one event in human history that has led to a spike in burning of fossil fuels. Okay, so that event is of course the Industrial Revolution. So 1850, right? This is a very important one because this is where Industrial Revolution took place. So with the Industrial Revolution, mankind basically embarked on technology, okay, use of steam engines to churn, to supercharge their development. Okay, be it in terms of manufacturing, in terms of transportation, in terms of farming. This was the one thing that allowed mankind to accelerate in terms of our development. But the side effects, of course, when you do burning of fossil fuel to churn machines, the movement of machines, right, you release carbon dioxide. Okay, this is one of the side effects, and you release methane to the animals and nitrous oxide as well. So these are the problems that come with this. So when you're talking about man-made, okay, anthropogenic factors, what are your key emissions? These three are our key emissions. Okay, three key emissions. You must know this. You must know what the key emissions are because they help you explain why this anthropogenic factor is key. Okay, so like we've seen his face before so many times, right? So if you track into nearer history, 1880 onwards to nearer to where we are, you will see that the trend of atmospheric carbon has been increasing rapidly. Okay, the blue line here is carbon, atmospheric carbon, right? And the red line is temperature. So there's actually a matching trend, right? So note when you're talking about the red line, once again, like we always talk about when describing graphs, this is not a gradually increasing or rapidly increasing smooth graph. This is a fluctuating graph. Okay, but generally the trend is increased. So it's fluctuating on an increasing trend. Okay, so temperature has increased in tandem with the carbon dioxide amount that's found in Earth's surface. Okay, atmospheric surface. So this should clearly show us that there's a relationship already. Okay, so like we mentioned earlier, industrialization and growth in population, these are the two key causes that push this rapid worsening of climate change. More humans, you need more food, you need more lifestyle needs, you have need for more energy, and therefore you will have the production of more greenhouse gases. Similarly, industrialization, through developing to further your needs, you will release more and more of the big three. Okay, now this is one of the key, more very important things that you need to have a clear understanding of what is greenhouse effect and what is enhanced greenhouse effect. Okay, they are basically the same thing, but the second one is enhanced, means it is more severe, okay, of greater intensity. So greenhouse effect, right, is good. This is good. Huh? How do I change this to good? Good would be green. Right, so this is good. Unlike enhanced greenhouse effect is bad. Okay, so this is bad. Right, so these two general things you must keep in your mind. Huh? Greenhouse effect is good, enhanced greenhouse effect, too much of it becomes a bad thing. Why? Okay, so greenhouse effect basically is the trapping of the radiation from the sun, shortwave radiation from the sun. As it enters through the atmosphere, it hits the surface of the earth and it warms it up. Okay, as it rebounds out and tries to go into space, some of it is trapped and shot back into the surface itself, while the rest of the long wave radiation from the surface is released into the sky. Okay, so that is how we survive, how we have the Goldilocks temperature that allows for life to exist on Earth. If we didn't have the atmosphere of greenhouse gases, you would either have very, very warm days and very, very cold nights, and nothing would survive. So the greenhouse effect is good. It allows for life to survive on Earth. Okay? Now, when you burn, when you deforest, when you plant, you will mess with the greenhouse gases percentage in the atmosphere. When you burn, you release carbon dioxide. Okay, one of the biggest greenhouse gas emissions. So when you do deforestation, right, it is akin to burning plus removal of what is storing your carbons already. So all these things that you have actually stored the carbons in, the trees, once you've taken them down, the carbon, and you burn them or you use them for other things, some of the carbon is released back into the atmosphere. Okay, so when you have more and more of these, you will have enhanced greenhouse effect. Similarly, when you look at agriculture, right, planting, so you may be thinking, if I plant more vegetables, right, green vegetables and plants, it should help absorb, right? Unfortunately, it doesn't, because it does while it's growing, but the growing period is so short after, before it's harvested. The moment you harvest the thing, right, that's it. Okay, you're releasing the carbon back again. And it's actually worse for those of you who eat meat. Okay, I think this should come in, you should remember this, right, quite clearly. Okay, so if you are vegetarian, you don't eat meat, your consumption of, or your contribution to enhanced greenhouse effect would be the fact that you're removing some of this plant life. If you are not vegetarian, you eat meat, the meat produced is highly polluting in terms of greenhouse gas emissions. So cows is the prime example here. Cows do not digest grass easily. So as a result, they produce a lot of methane. Okay, methane. So this methane gas goes into the environment. It creates, again, enhanced greenhouse effect. Okay, is that all? Of course not. Humans being humans, with industrialization to build all the equipment that you have, right? Your cars, your phones, your iPads, right? These are all contributors to greenhouse gases. So if you look at your textbook itself, you will see examples, right, of all these things, and urbanization as well, as we all seek to urbanize. Okay, what happens when you're living in a city? The amount of power you need to consume, the amount of vegetation that you need to consume, actually increases. And because in the city you can pack a lot of people, so as a result, you do need to produce more food for these people. So this is a very big problem. Okay, so at this point, at this point, I would want you to go in and do question 1A and 1B of your gateway assignment 2. Okay, question 1A and 1B of gateway assignment 2. When you are done, come back and we will continue with the second video. Okay, so I'll see you later in the second video.